who are yet to join, please call them. We will begin the session shortly. Once again, a very good afternoon and a very warm welcome, everyone, to the second masterclass of our AI July internship. Before we dive into today's masterclass, let's do a quick recap of the last session. The last session comprises of Introduction to AI, Generative AI and its usage, deliverables and deadlines. So in this internship, you have two deliverables which you need to submit. Wherein, when I talk about the first deliverable, that is the artificial intelligence learning plan. The deadline of the learning plan is 26th of July. The link of the learning plan is already shared over a WhatsApp and the Word document that comprises of all the recordings and resources. When I talk about the second deliverable, which is placement assistance learning plan, same, the deadline of this deliverable is 26th of July. Also, we will be sharing the AI badges over LinkedIn of students, those who have completed the courses and they have earned the badge. Also, CSR Box team will be sharing the captions over a mail to those students, those who will be completing the batches on 25th of July probably, so that you can post the batches on 26th of July on LinkedIn. For today, we have Amit as a guest speaker. Amit is an entrepreneur and as an AI consultant from IBM SkillsBuild. He has done his bachelor's in electronics engineering and specialization with AI. He is currently pursuing his research in NLP. So now you can understand, like you all, he is also passionate about AI technology. Without further delay, let's see what he has in his store for today. Over to you, Amit.
Thank you so much, Rashika. Hello, everyone, and welcome to our second masterclass on generative AI. We are going to learn a lot in this masterclass today. And I welcome you all to this. We have shifted the masterclass to a little bit earlier. That means that we are doing it at 1:30. We were about to do it at 4, right? But you have joined in like so many participants, and I welcome you all to this golden hour of studies. Why I call this the golden hour of studies is because 99% of people don't prefer to study in this hour, right? Right after lunch, 2 hours of heat and all, they don't prefer to study in these hours. But you are here and you are learning and you are taking a step towards your own betterment. So I welcome you all in this journey. We are going to learn a lot together. And I'm again situated in Ahmedabad. It's a lovely weather there. It's a little sunny today. I hope that you are also enjoying the same weather that you are in your own states. Without further ado, let me share all the slides that I have created specially for you. and we are going to have a lot of fun in today's class. Today's class is a little bit of more theoretical, so you'll have to focus a lot in the class, but I have designed my questions for you so that you are focusing in this class. So let me share these slides which I've designed for you. And it starts right there with the first question. Remember that we were doing all these poll questions last time. So today also we are going to have these poll questions, and I'm going to flash them on the screen. And you have to choose the right answer from these poll questions. Let me just quickly start with the first question that we have today. And it is here. So what is the programming language that you should learn in 2024? And India is a land of consultants, that I say that everyone is a consultant because we give advices to all of the peoples all the time. So this is one advice if you want to give to anyone. What is the programming language that you should learn in 2024? Is it Python, Java, C, C++, React, or Node, or none of the above? All right, quickly type in your answers. You just need to click on the right answer that you believe is the right language that you should learn in 2024, or you should suggest someone to learn in 2024. All right, it started with a brilliant answers from all of you. Almost 450 participants have answered in this poll right now. I will just open this poll for 1 minute only. So you will have to be a little bit quicker in answering today's questions because we have a lot to cover and we have very less time for all these question answers and all. Okay, so 78% of you have participated. I'm not going to wait any longer. I'm just going to show the results. So 73% of you are saying Python as the main language that you should learn in 2024. 13% of you said Java, 6% of you said C, C++, and 6% of you said React and Node, and 2% of you said none of the above. Okay, if you ask me which language you should learn in 2024, I fall in those 2% category. That means that you don't need to learn any of these languages. Although these languages are very, very powerful, you will, there is a disclaimer that I will share by the end of this session about what language you should learn in 2024. Python, Java, C, C++, React, Node, all these languages are very powerful. You should learn them in 2024, but I fall in the category of those 2% people. That means 10 out of you who say that you don't need to learn any of these programming languages in 2024. What you need to learn in 2024 is the only programming language that you need to learn is English. And why is that? All right, so if you have learned programming in your, if you are engineering graduate, or if you are doing any course, and if you have learned any programming somewhere, so this is a question that comes often in these courses, right? Write a program in Python to find the factorial of a number. Any language for that matter, C, C++, Java, Node, React, whatever language you want to code it. Okay, so if I want to write a program in Python to find the factorial of a number, I can do it with two ways: by using the for loop or by using recursion. So there are two ways two ways to write this program, right? So if I were implementing this program in Python, I would need to know all of these things. I would need to know the variables. What are the variables in Python? And the if-else statement, how to use that in Python, how to write that, and what is how to use that. Python for loop, the understanding of for loop and the iterations, and Python recursion, the concept behind recursion and all, how to call the function within a function, right? So these four things I need to keep in mind if I'm writing a program in Python to find the factorial of a number. Although it's a very, very simple program, not very complicated, I will still take 20 good minutes to write this program. I will go and type, I will use the logic, and I will think about a lot of things. But in 2024, the time is amazing. Like, you are living in the best of the time, right? Because if I want to write a program in Python to find the factorial of a number, I just need to understand English language. So or if you want to create a web app using Python and panel to count the number of words in a sentence, whatever you want to create, you just need to code it using English language. How to do that? You must have been familiar with this very window that I'm going to share right now. So I'm sharing my screen. And I'm just going to go to another tab, and I'm going to type the most searched AI tool in the market right now. So I'm going to type ChatGPT, and I go to ChatGPT. I already have logged into ChatGPT. So I'll just click on this try ChatGPT. And it will take me to my ChatGPT page. Okay. Yeah. So I'll open a new chat. Remember, I said that you just need to understand the language of English. So I will just write act. Okay. Act as a programmer. Write a program. What is happening? Program in Python. To find the factorial. Okay, this is interfering with this, so it will not do now. Factorial of a cube. Okay, so if I hit enter, then what ChatGPT does is I just wrote it in a simple language. I just wanted ChatGPT to know that, okay, act as a programmer, write a program in Python to find the factorial of a given number. Now, ChatGPT is returning it in two ways. One is the iterative method, that is using the for loop. And the next one is using recursion, and the complete program is here. Okay. So it is acting as a programmer, so it is giving me both the choices. If I have not written act as a programmer, it would have just written me a Python program using the best method, which is recursion. Okay, what I will do is I will quickly open my Google Colab, and I'll just go to whatever. So I'm using Google Colab because this is one of the easiest IDE to use right now for Python programming. And I'm going to create a new one. So I'll create a new notebook, and yeah, it's going to take some time. All right, so what I will do is I'll go to ChatGPT and I will copy this whole complete code and I will just paste it here and I run this. Okay, so it will connect to a virtual running environment and then it will start the program. Let it just connect to the environment. Okay, it's going to be green soon. 3, 2, 1, green. Yeah. So now the program will be deployed in this, and it's asked me to enter a number. If I just enter any numbers for that matter, let's enter 10. Okay. Okay, 10. And what does it do? The factorial of 10 is 3628800. So I just instructed the ChatGPT or any large language model for that matter in plain English language, and it wrote a complete program for me. Okay, let's get back to coding with English, and let's create an app that counts words in Python. Okay, so let me just go. If I want to create an app that is going to count numbers in Python, then again, if I do it completely with programming methods, then I will have to scratch 20-30 minutes of my brain. I'll have to think about the algorithm to count the words and use the loops, if else statements and all that. But if I don't want to do that, I'll just give an instruction to ChatGPT in plain, simple English language. I'm just saying I want to create a web app using Python and panel to count the number of words in a sentence. And it just starts. Yeah, so it also gives me that you need to install the required libraries. That means I need to install this a bouquet library, and then here is a step-by-step method of how to implement an app. Okay, just copy the code from here. I'll go to this Google Colab. I'll just delete all of these things here, and I'll just paste this. And let's see if my program runs properly. Okay, so it has launched it in a server. So it looks like this, right? There is a problem with the code. Okay. So let's do this. I am programming in, doesn't work like this. Lab, and it just changes the code. So you need to set up an environment and you need to install the libraries. So you can, if you run into any problem with the code, you can also tell ChatGPT that this is the problem that I'm getting. I'll let you just, so I just needed to add app.surveyable, I guess, because the app was not surveyable. So I will just add this to my code and let's run it. All right, so it's already satisfied because it is doing it from the back end. And yeah, so it has created me an app here, and it looks, I can do this here. So count the, all right, it always interferes with me. The number of words. Okay, just let's do that. And there should be a button. Yeah. So, there is no button in this, so I will just tell ChatGPT that there is no button in this, and I will add a button. So the main idea behind telling all of that was not to teach coding through ChatGPT today. I will do this in the next masterclass. Was just to say that, okay, yeah, screen sharing is paused, and I need to share it again. Okay, so the idea was to say that in 2024, if we want to do a complicated process like programming, we can use these large language models or ChatGPT and all these AI tools, which can understand our simple, plain English language, or any language for that matter. ChatGPT understands a lot of languages, and English is one of the prominent one that a lot of people use. Not only just creating this code with English, we can also paint with English. That means that I just need to instruct ChatGPT. This painting I have created with the help of ChatGPT, and I wrote black horses grazing on tall, juicy grass in an expensive steppe, capturing moment and grace, sunset casting a warm glow over the scene, shadows elongate beneath the majestic equines, prairie grasses gently swaying, sense of freedom palpable, digital painting, golden hour lighting, and high dynamic range. So I told ChatGPT that this is what I need to generate, and it generated me a perfect image like this. And again, if I refine my prompt a little bit more, and I want to just create a waterfall scene where everything is very, very crystal clear, and it is being shot like just a photographer has shot this. So I will just tell ChatGPT whatever I want to create: a vibrant blue waterfall cascading into a large natural pool, water mist rising from the churning water at the base, and cast in lush greenery, sunbeams piercing through the canopy overhead, high shutter speed to capture the motion of the water, natural light, ultra clear, and 8K. So if I can talk to these AI tools in a plain English language, and if I have a good grasp of English language, that I can not just code, but also can create all these amazing, amazing photographs as well as pictures using the ChatGPT and all the AI tools that we are going to learn in today's class. All right, so a little bit of poll time again. If you have used ChatGPT before or not, how many of you have used ChatGPT or have a ChatGPT account? It's a never have I ever question. Don't worry, you don't have to drink anything if you don't have done this. Okay, so question 2 is live. How many of you have a ChatGPT account and have used ChatGPT before? Please answer this question. If you have not used this, then never have I ever. And if you have used ChatGPT account, then just click on I have. I will open this poll for the next 1 minute, and we are going to not lose time on poll today. So you have to quickly click on these poll questions and let me know if you have a ChatGPT account and you have used ChatGPT before. So 97% of people right now are in I have category. That means you have a ChatGPT account and you have used ChatGPT before. If you have used ChatGPT before and you have an account, then this class is going to be amazing for you because you are going to learn how ChatGPT actually generates the text that it is generating, or how ChatGPT actually generates the images that it is generating. So we are going to learn in depth the principle or the intuition behind all these AI tools generating text and these images, or code for that matter. So how it generates all these things, we are going to learn this in today's masterclass. It's over than 1 minute, so I'm going to stop this poll. Remember, you have to be very quick in today's polls, because otherwise we will not be able to finish this workshop on time. Okay, so I'll just share the results with you, and 96% of people are saying I have used ChatGPT, and you have a ChatGPT account. It will come in handy when we will be doing prompt engineering in next masterclass. Also, in today's masterclass, if you have a experience of any of these tools, then it will be a better experience to learn these tools. If you have not used ChatGPT before, no worries. We are going to create a ChatGPT account in next masterclass. But before that, let's solidify our concepts about ChatGPT and how it works. Okay, so let's get to this section where I welcome you all to the world of generative AI, where we cannot even just generate code with the help of ChatGPT or text with the help of all these AI tools, but we can also create images. There are tools which are used to create audios, and also there are tools which can create video clips just by giving them a single prompt. So it's an amazing world to live in right now, and it's a very right time to learn about generative AI. So I welcome you to the world of generative AI. Let's talk about a little bit of disclaimer that I give always before the class. Even after coding with ChatGPT, I'm not a supporter of coding with ChatGPT. However, it will make your work very easy. If you are coding with ChatGPT or any other AI tool, you still need to have basic understanding of programming. You need to know where the bugs are. You need to know how to debug those programs, so that you are not spending much time on ChatGPT asking it to debug the code that you are writing with the help of ChatGPT. Okay, so you still need to have basic understanding. Also, having solid understanding of algorithms and jargons that are used in programming will help ChatGPT to write all these programs effectively for you. Also, you need to have a critical thinking mindset to solve the problems. So actually, programmings are done to solve some problems in the world, right? So you need to have that critical thinking mindset, how to solve these problems. Then only you will be able to use ChatGPT to design programs for you. It will write a program, a simple program like calculating a factorial or counting words in a sentence. It can write all these programs beautifully. But for coding something which for coding a problem that you want to solve, you will have to have that critical thinking mindset. You will need to know which technology you want to use. If you want to create something like a web crawler or something like Google search, then you need to know that you are going to use breadth first search algorithm for that. So you need to have that understanding of the algorithm that you are going to use, and ChatGPT will write those programs for you. What I wanted to say with the generative AI introduction that I gave, that you don't need to type everything on the computer in the world of generative AI. You just need to have that problem solving knack. All right, and let's begin with what we are going to learn today. We are going to learn about generative AI, the history of generative AI, text generation. I'm going to focus on two things because these are my particularly areas of research and expertise. So I'll be talking about natural language processing, that is text generation, and how text is being generated with the help of AI. And second, we are going to cover how images are being generated with the help of AI. That means the image generation part. So two parts in this. One is text generation and image generation. We are going to explore transformer architecture. That's the building block of large language models. And we are going to learn how to create our own large language models from scratch. So there is a lot in today's masterclass. And again, the rules of class are very simple. I will have to use English because there are non-Hindi speaking states students also involved in this internship. And the difficulty of the class is medium to hard level of tech understanding. So some of you might feel it easy. Some of you might feel it challenging to grasp. Those who are feeling it challenging to grasp, there is also going to be a YouTube live of this session. So you can always go back, refer to the YouTube live, and can understand these concepts again. Also ask questions. I remember that last time all of you asked amazing questions that I love to answer by the end of this masterclass. Today also we are going to keep a good half hour after this masterclass just to solving your doubts and your questions about generative AI. So if you have any question, so you feel free to ask in the chat box by the end of this class. I will solve most of the questions that I can read. Also, if you read, you will learn. If you hear and visualize, you learn more. But if you participate, you learn the most. I saw in the last masterclass, 99% of you were participating either in the chat box or in the polls that I have. So please participate. Unless you have a memory chip installed in your brain and you can record everything and learn everything, please grab a pen and a paper so that you can write notes so that you are learning in the right way. Okay, so let's begin. If you have a pen and paper nearby, just grab it there. Otherwise, just keep attention on this class. Okay, so let's begin with what is generative AI, the definition of generative AI, and why is it so popular? Generative AI is made up of two terms. First one being generative. And by generative, we means we are creating new content. We are not creating any old content. We are not copying it from somewhere or displaying that result. We are generating a new content like audio, code, image, text, or video. Whatever we are generating with the help of computers, if we generate it with the help of AI, then that AI will be called a generative AI. Okay, artificial intelligence, you already know from the last class, is just a computer program to mimic human intelligence or to a computer algorithm that can do tasks similar to how humans work. Okay, so just like human being will write an email or an essay or a letter, generative AI will write that in similar manner. Okay, so generative AI is generating or creating new content, which is audio, code, image, text, or video with the help of AI, which is artificial intelligence. And where have we seen generative AI earlier? Okay, so it's not that ChatGPT was launched in 2018 and it's been 6 years after the launch of ChatGPT. But before that, we also have seen generative AI. And that was not very popular, and we did not call it generative AI, but in true sense, it was a generative AI. Generative AI is one of the fancy terms which came into market after all these ChatGPT, Midjourney, and Gemini, all these AI tools by different companies. Okay, so this classic case is also a case of generative AI where Google Translate, I'm sure that a lot of people have used Google Translate in their life before, and this one you must have seen in televisions. So mutual fund ads. So mutual fund actually is, the ad was actually created in English. Mutual fund investments are subject to market risk. Read all scheme related documents carefully. But the people who use it in Hindi, they use a Google Translate version of that. So mutual fund निवेश बाजार जोखिमों के अधीन है, योजना से संबंधित सारे दस्तावेजों को ध्यान से पढ़ें. It does not make some sense. There is some disconnection क्योंकि I don't understand कि बाजार जोखिम के अधीन है, that what that means in Hindi, right? So there is some disconnection, but this has been used in all of the ads of mutual funds so far. And Google search was launched in 2000 and Google Translate was launched in 2005. That means that's 17, 18 years, 19 years for that matter. 19 years back, we were seeing generative AI, where it was generating a text in another language. We were inputting it in one language and it was generating it in another language. Where have we seen generative AI earlier? Okay, so all of you must have said, hey Siri, Alexa, or okay Google once in your lifetime. I'm very sure that you must have said these things if you own a smartphone. Just to talk with it or just to do some of the function. Okay, so there's an example that I do when I sleep. So hey Siri, I just say hey Siri, Alexa, or okay Google, whatever the device that I have, set me an alarm for 6:30. And this is the input that I give and in a natural language. And the generative AI, what it does is it sets the alarm. It also talks back. It generates a voice in the response of what I am talking. So it says your alarm has been set for 6:30. So it generates an audio response. So this is also a case of generative AI, and it was launched in 2011. That means 12 years back. And we also have seen generative AI in search results as well as text that we generate. So in our smartphones. So what Google search does is it generates some words, these words, in response to what I'm typing. So it is predicting some words in response to what I'm typing. So if I type I want to, it predicts that Okay, do you want to say I want to play games? Do you want to say I want to break free? Do you want to say I want to learn, or I want to sell my phone? And that prediction it is doing by searching and counting the number of times I might have searched all these things, or I prefer to search all these things. And similar thing happens in smartphone where you are typing something like please send me an. So it suggests you email updated or update. So it depends on the number of times I have typed something in my smartphones, or number of times generally people type something. So it predicts the next word in the sentence. So Google search, it came in 1990s, and this type of AI is called language models or language modeling. And we have been doing language modeling since 1990s. That means that 30 years back, almost 30 years back. Language modeling we will explore further, and the upgraded or updated version of this language modeling is what we see ChatGPT and large language models in our today's life. Okay, so generative AI now is not just ChatGPT. I tell ChatGPT, but I'm not an agent of ChatGPT, and ChatGPT doesn't pay me to do this class. I do it in behalf of IBM. So, but still, I use ChatGPT because a lot of people are familiar with ChatGPT and it is easier to understand. The name is a household name now. There are other generative AI tools in the market. Gemini is one, which was called Google's Bard, which was a kind of like an adversary to ChatGPT that Google launched. Midjourney is one to Midjourney is one to generate images. There is Billboard, and there are many, many more. Even all these social media like Instagram, Snapchat, they are designing their own AI. Even Meta has launched its Meta AI recently, right? Okay, so now we are talking about generative AI, and we say that generative AI, these are these generative AI tools, but what can it do? It can do text generation. That means it can write essays, resumes, articles, blog, posts, poems, stories, recipes, instruction, whatever kind of text that you can think about, it will be able to generate that text for you. Okay. Image generation, like posters, images, paintings, logos, icons. We saw how we could generate images just by writing, just by giving instructions. So it can generate images from text. So we are not using Photoshop. We are not using any of the tool that we are using that we were using earlier to generate all these photos. But we are just instructing the large language model in plain English language. It can also generate code in languages like Java, Python, C, C++, HTML, any language for that matter. It can generate that code for you. We saw a recent example where it was generating me a Python code. Right, and it was not generating it by me particularly typing those code in the IDE, but it was generating code from simple instructions. Right, it can also generate audio. It can generate audio from text. So I was recently listening to a very, very interesting song by Kishore Kumar in the voice of Modi ji, and that was very, very interesting to hear. So it can generate audio from text, audio like instrumental music, sound, background score, etc. It can also generate videos, and right now only small clips are being generated from text. So Sora is an example of Sora is the latest technology by OpenAI, which can generate videos, and you can just give an instruction and they can generate amazing videos for you. Just a little segue from this. So I used to own a cafe in back in 2023. And I live in Gujarat, so here we celebrate Navratris, and Navratris are very, very popular in Gujarat. And the Zomato representative, my cafe was on Zomato, and the Zomato representative, he came to me and he said that, I'm giving an example of video generation for that, if you are confused what I'm talking about. So he came to my cafe and he said that, sir, what we will do is Navratris are coming and the sales will be booming and you need to market your cafe. So we will be doing an ad, and Ranveer Singh will be talking about your cafe. So you just need to create a jingle and Ranveer Singh will be talking about your cafe. I was very, very excited. I have never met Ranveer Singh in my life. And I was like, okay, and how much will that cost? Because Ranveer Singh is kind of like very, very, he must have like high fees. And he said, it will just cost you 5,000 rupees. And I was amazed by hearing this. And I was like, okay, Ranveer Singh will just talk about my small cafe and it will just cost me 5,000 rupees. I mean, this is a very big deal. And he said that just write a jingle for your cafe. And I wrote So my cafe's name is the Dosa Cafe, and I wrote Dosa Khana hai to Dosa Cafe jana hai. So this was a simple jingle that we made, and there was something behind that, some text behind that also, and then so he just entered this, and an ad was being generated, and Ranveer Singh was lip syncing the same thing in the same voice that he talks about, and yeah, he was just he was just there in the video, although he never shot that video, he never heard about my cafe, he didn't even hear the line, but with the help of these video generation AI tools, they were able to record a lots and lots of videos of Ranveer Singh, and they were able to train an AI system that can mimic Ranveer Singh's lip syncing as well as voice. And that's the world that we are living right now. Just by spending 5,000 rupees, I could have an ad of Ranveer Singh saying about my cafe. Although that ad didn't run very well, and we did not get so many leads from that ad, but that's another story that I will tell in some other time. Okay, so a quick quiz time before I move further into deep discussions about how text is being generated and how images are generated. Let's test your knowledge about generative AI. So I want you to tell me which one of these is an example of generative AI. Okay, so we have been learning about AI for the past 3-4 days, for that matter, in this internship. So which one of this is an example of generative AI? Okay, think and then answer. A lot of people they are just randomly clicking anything. Okay, so using AI for predicting weather that we were using in that we were doing in the last class, the prediction model, is it a generative AI? Writing emails and articles using AI, is it a generative AI? Detecting cancer cells with the help of AI, is it a generative AI? Or recommending content in a Netflix using AI, is it a generative AI? So just click on the right answer. I will only have this poll live for 1 minute. So let me know what is your right answer. Okay, so 45 seconds have already been spent. You have 10 more seconds and I'll be ending this poll. So ensure that you are participating max in this class. Okay, so I'll wait for 10 more seconds because students are still participating and the number is rising more and more. If I reach 75% of participation, I'll be good to go. Okay, so it's stopped at 69. So I request the people who are not participating, please participate in this poll so that I know that how much you are learning from this masterclass and how you already, what you already know about this. So in the last masterclass, a lot of you taught a lot of things to me that I was also being unknown of by using these polls as well as the chat boxes. So I am very, very, very much in gratitude to all of you, those who are participating in these polls as well as in the chat boxes. So I will just end the poll because we are moving ahead in this class, and the results are 70% of you are actually right, because if we write emails and articles using AI, that will be a case of generative AI because it is generating these text emails and articles using AI. So it is generating something new. So that's why writing emails and articles using AI would be the best answer. If we are predicting weather, then we are using machine learning, that's or any other algorithm for that matter. So we are not actually using generative AI for predicting weather. Detecting cancer cells, again, will use computer vision, and it will not generate something new. It will be classifying cancer cells into cancer or a healthy cell. Recommending content in Netflix using AI is a probabilistic model. That means that you use we basically use Bayes theorem to classify all these content which you have watched, and then it will recommend the content to you in that form. So it's not actually generative AI. So the right answer is second, and congratulations to 70% of you for answering that the right answer. Those who have answered wrong answer, no worries, because every wrong answer also leads to the right answer. Every failure is a path to success. And being an entrepreneur, I have learned this the hard way, but that's the way to go. Okay, so let's go to our class. So what we are going to learn about in today's masterclass is in-depth session about text generation and image generation, how text is generated and how image is generated. Okay, so let's dive into how text is generated by ChatGPT. Now we are seeing that ChatGPT can generate all these amazing texts. It can write me essay, it can write me all these things. But in reality, how is that text being generated by ChatGPT? Let's understand the underlying principle of it. Okay, the intuitive idea of how it is generated. Okay, so let me just let me just share my screen one more time. So actually show you again the working of ChatGPT and how it was generating text. So let me open a new chat and write a poem. Okay, so again, poem on cats. Okay. All right, so it has started generating, and just look at how it is generating. Okay, so let's get the feel of the generating. What is it generating? So it has started generating, and all this it has generated. Okay, so just carefully just focus on how it was generating, and let's move on to our session. Okay, I hope that I'm sharing my right screen right now. Okay, so how text is being generated by ChatGPT. So remember these prediction models that we were talking about, the language models, the language modeling, like Google search and your smartphones. So the similar technology is used, not the similar one, but we call them large language models. But let me just introduce you to this. So ChatGPT generates text by predicting the next word in the sequence. You saw how ChatGPT was generating the text, right? So it was just writing the next word and the next word only. So it was generating word by word. It was not giving me the whole poem at once. So word by word, it was generating. So this is not a fancy animation that OpenAI has put on ChatGPT that it should occur like this. It is actually how ChatGPT is generating the text. So ChatGPT actually generates or predicts the next word in the sentence. And by predicting the next word in the sentence, the algorithm is such that it generates the whole text. How does that prediction happen? And what is happening inside ChatGPT? We will explore more. Okay, so you remember the language modeling I was talking about? We were predicting the next word in the sentence, right? So if I type, I want to, so Google will recommend me the next word in the sentence. And it will depend on how much time I have searched that word earlier in my search history, okay? Or how much time similar people like me are searching these words. So if I type, I want to, and it will give me these word preferences. So cook will be the next word generated. It can be either of them, cook, play, watch, work, because I frequently watch cooking videos. So it will give me this cook on the priority, that means it will be on the top. And I seldom type I want to work, because who wants to work, right? So that's why it will give that a lowest priority. So the thing that I will search more, it will be on top priority, and it will generate that word, and it will generate the follow-up word also. So I want to cook, and then food. I want to play. It can generate the next word, games or music. I want to watch movies or sports. I want to work. So it can generate the next word in the sentence. So language modeling was what being used by Google search results, and we were using searching and counting to predict the next word in the sentence. What ChatGPT uses is it uses a large language model. So the technology of language modeling, we have changed from that, and we have implemented these large language models where we are modeling the language not on the base of search and count. So we are not using any logic of if Amit searches about cooking, then predict cook. Okay, so we are not using that logic anymore. We are not counting, and we are not searching it in the database, but we are using something which is called large language model. We are still predicting the next word in the sentence. Okay, so the underlying principle is same, that we are predicting the next word, but we are using large language models. What are these large language models? I'm going to explain in this masterclass today. Okay, so let's explain. Let me explain it with a simple example. So suppose you ask ChatGPT, what is the tallest building in the world? Okay, and what ChatGPT will do is, the first step that ChatGPT does is it segments or it divides the sentence into tokens. Remember, I was talking about GPUs, which are very, very efficient in processing all these in processing parallelly. So what ChatGPT does is it doesn't understand the whole sentence, right? What it understands is, what the underlying principle is, it converts these sentence into small segments called tokens. So if you go to this platform.openai.com/tokenizer, you can see how ChatGPT kind of like arranges all the sentences into tokens. So earlier, before ChatGPT and before this structure where we were not generating tokens, we were using these technologies called RNN, which were recurrent neural networks, and LSTMs, long short-term memory. So in these, we were feeding our text in series. But what happens in series way of feeding the text is there is a bottleneck that happens. It cannot remember large text because all of the text is being fed in series. So it needs to understand which come first. And if you have a very big paragraph, it forgets whatever was generated before. Okay, so that problem was being solved when we segment it into different tokens and we feed all these tokens in parallel. Okay, so if you go to tokenizer by ChatGPT, you will be able to see what are the tokens that ChatGPT generates or divides a single sentence into. So the tokens can be words, they can be symbols. In this case, this question mark is also a token because it's a symbol. So all these words, what is the tallest building in the world? World, the, in, building, tallest, the, is, what? They are the tokens. So this sentence is divided into 9 tokens, and these 9 tokens will be fed parallelly to ChatGPT. Okay, so what is inside ChatGPT we will discuss later on, but right now we are just using this black box concept. So we are treating ChatGPT as a black box, and we don't know what is inside ChatGPT. And what happens is it feeds all these words in parallel to ChatGPT, and now ChatGPT generates the next and the next word in the sentence. Okay, so the next word in the sentence will be the. Okay, why? Because all the answers, they start with the. It's a question, and the answer will be starting with the. Now, what happens is this the will be added to the input. Okay, so whatever ChatGPT generated, and after this, the first word in the sentence, which is the, and the will be added to input. Now, all these words with the, what is the tallest building in the world, and the will be fed into ChatGPT, and next word will be generated or predicted. The next word will be tallest, and that tallest will add to the input. All these words will again go parallelly to ChatGPT, and next word will be generated, which is building. That predicting, it is predicting the next word, right? It is predicting that, okay, after question mark, the comes. After the, tallest should come. After tallest, building should come, right? And after building, in should come. So it is predicting in. And after in will also add in the sentence and in the input, and the input will become what is the tallest building in the world, the tallest building in, and the next word will be the. And the will again add to the input, the next tallest building in the, and next word will be word. And then word will add into input, the next word is generated, which is. Is will again add to the input, the next word is Burj, because Burj Khalifa is the building which is the tallest in the world, right? So Burj will be generated, and then the next token, which is Khalifa. And after generating the whole answer, ChatGPT will generate the last token, which is called EOS token, or end of sequence. Okay, it is similar to how full stops are there in English language. Okay, so what is the tallest building in the world? It generated word by word or token by token. The tallest building in the world is Burj Khalifa. Okay, and this EOS will transform to the full stop, and that's how it will generate this whole sentence. Okay, if we have time, I will just show you the same thing in ChatGPT, and let's go to our Google Chrome. Let's type in a new one, and what is the tallest building in the world? Okay, and I hit enter, and see it is generating the next word only in the sequence. Okay, it is not generating the whole paragraph together. It was just generating, although I told you in a very intuitive way, and it was very slow in generation because I was teaching, because for the teaching purposes I was very slow in generation. It happens very fast because of these GPUs. They are very good in processing these things parallelly. So it happens in a blink of eye. Okay, so it was generating text in that way. Okay, so let's move ahead. Now we know that ChatGPT generates all these, or it predicts the next and the next token in a sentence. That means that it is actually predicting this. So how does it predict? What is the underlying mechanism? What is the algorithm? And how could we make computers understand language? Because computer doesn't understand language, right? It only understands ones and zeros. So how is that we were able to make computer understand language is what we need to learn. Okay. So we were talking about large language models, and ChatGPT is a large language model. So we will talk about these large language models and what are these. So what happens is these large language models, they are actually taking up a large or a very big amount of data that we are getting it from internet, and we are compressing it into a file called a parameter file, and we are using a code to run this parameter file. So basically what we are doing to create this large language model, or what are these large language models actually? So they are so suppose we have text. Suppose we are creating ChatGPT, which can generate text. Okay, so what we will do is we will take all the text in the whole world. Whatever there is text in Wikipedia, social media, GitHub, Pinterest, blogs, articles, all these text in the world. And if we could somehow compress this text into something, and then we could run a code which could understand all of the text that we have in the world, and that could predict the next word in a sentence. We will have a large language model, right? So large language model actually two files. One is the parameter file, and one is the run.c file. Okay, so basically we are compressing all the text in the internet. It's not a lossless compression like GIF files. It is like zip files. It is basically a lossy compression. That means that we are compressing all the text that is in the word into some form of a gist. Basically, whole of the English language, we are modeling it inside a program. Okay, so and then we run that on cloud or GPUs. So ChatGPT took 60,000 GPUs and that to 100 GPUs to train their large language model, and they ran it for 60 days continuously. So all the information in the world, all the text that we have from GitHub, from Pinterest, from Wikipedia, we are compressing this and we are getting these parameters. Okay, and these parameters are actually being stored somewhere in a cloud so that we can remotely access it. And the combination of these two files, the parameter file and the run.c file, will make the large language model, and we can talk to this in natural language. But how to get these parameters is the intuition that we need to learn. Okay, so let's learn how we are getting these parameters. Okay, so just to tell about parameters and to introduce you to it. So this is that neural network that we were talking about in the last time, right? So in the last lecture, we were talking about that we are predicting that an image is a cat image or not using these neural networks. And there is some adjustments that is happening in these neural networks. And those adjustments or the value of these adjustments are called parameters. Okay, so weights and biases. So basically each node is connected to another node using a weight, using a number which we call a weight, and that weight determines whether that neuron will be fired or not. Okay, so not to go deep into parameters and deep learning, because that will be very difficult topic to cover, but to get a gist of what parameters are. So in a small neural network like this, we have these three nodes, and there are 8 nodes here. There are 8 nodes here and 2 nodes here. So these 3 nodes are connected to these 8 nodes. So number of parameters will be 3 into 8 equal to 24. So 24 number of parameters when each node is connected to other node. And these 8 nodes are connected to these 8 nodes. So in total 64 parameters. And these 8 nodes are connected to these 2 nodes. So in order 16 parameters here. And this term which I'm adding here is called bias. So here it is 4, here it is 6, here it is 6. Okay, here it is 8, here it is 6. Okay, so this bias we add to adjust our model to predict correctly. So basically what we are doing is we are taking up all the text that is in our internet. We are putting it in one file, and from that file we are training our parameters. Okay, training our neural network, some adjustment in these weights and biases. It is working like human brains. It is making some context between all this information, and it is predicting or giving some output. Okay. So if this toy neural network has 122 parameters, imagine that ChatGPT has 175 billion parameters. So the scale of ChatGPT is very large. That's why they needed 60,000 GPUs to continuously run for 60 days to compress all the information that is in the internet to get these parameters. Okay. Now, if you want to create your own ChatGPT-like model, so suppose I believe that you are brilliant minds that are in this internship because you have taken a step towards learning AI. In the future, if you want to build something like ChatGPT, what you will require and how to build your own large language model, what is the conceptual understanding behind it? Whether you implement it on Python, whether you implement it using C, whether you implement it using Java, that's a implementation part, right? So we are talking about the concept or the conceptual understanding of what a large language model is and how it works. So suppose in future or right now on also, if you want to create a large language model, you will need these 4 things. Okay, so you will need a lot of data. That data we call corpus. You will need transformer architecture. I'm going to explain this in detail. You will also need GPUs, and you will pre-train your transformer architecture, pre-train your GPUs using this transformer architecture, and later on you will fine-tune all of it. Okay, so I will be able to teach all this concept in very simple language. So just right now, I just wanted to show you the ingredients that you need to create your own large language model. So first is you need to have a lot of data that we call corpus. We need to have a transformer architecture. That means a way to make computer understand human language. You need to pre-train it with all the data that you have using transformer architecture. Of course, it will take a lot of GPUs to pre-train and a lot of money also. So ChatGPT took $100 million in funding from Microsoft to train their GPUs to create ChatGPT, right? So that is called pre-training. That means you pre-train your model using the data that you have. And finally, if you want to use that model, that means that you want to deploy that model to the world, then you will fine-tune it according to your need. If you want to design a chatbot for your factory, then you will put your factory data into it, and it will respond your factory answers. If you want to open it for general public like ChatGPT, we fine-tuned it for general answers. Okay, so large language models, how to make them, let's learn. The recipe of making a large language model is very simple. First, we need to make a large corpus. Okay, we need to have a large corpus. Second is to train the language model, and third is to fine-tune the model. 3 steps only involved, lot of money, lot of GPUs. If you have that, you will be able to create your own large language model. Let's dive right in to how to make our large language model. Okay, so first step is to make a large corpus. That means we need to have the data, right? We need to have the data that we need to train our large language model in. So what basically the researchers did was we already have all of the text in English or whatever language that you are creating it for. Suppose you want to create it for Hindi, then you will be able to, you need the Hindi data actually. Okay, so right now we are creating for English. The similar goes for any language. So to build a corpus, that means corpus is the word that we use for the data that we use for large language models. Okay, so to build a corpus, we will use these web crawlers. So these web crawlers are nothing that, but they are a kind of program that go to every website in the world and they extract all the text from there. So they will extract all the text from there and they will put that text in a file, which we call a corpus. Okay, so we will use web crawlers, and we will go to Wikipedia, Quora, social media, GitHub, Pinterest, articles and blogs. So Wikipedia, Quora, social media for text and images, GitHub for programming, Pinterest for pictures, articles and blogs for again text and images. Okay, so we take all of that data, all of the text that is in the world, and we make a file which we call corpus. Okay, understood? Now let's move ahead. Second step. Okay, before I move to second step, it's because I have talked a lot, and I feel that you should also get involved in this masterclass. So this is a question that I have kept for here. So we are learning large language model. Before I move into pre-training, I just want to know how much focus you are in this class. Just answer this question: how ChatGPT actually generates the text? The question is live on your screen now. Okay, so we will take 1 minute to answer this question. Please read the question carefully and read the options, and then try these options. Okay, so I will take 1 minute because of the time limit. So I will be, after 1 minute, I will be stopping this. Okay, so how does ChatGPT generate text? First option is it generates paragraph by paragraph. That means it is generating paragraph. Second is it predicts the next and the next word only in the sentence. Third is it predicts the whole next sentence and displays it. And fourth is it generates the whole document at a single time. Okay, so how does ChatGPT generate text? We were talking about ChatGPT and how it was generating the text, and we were talking about large language models. So let's see if you were focused in the class or not. So if the participation exceeds 75% after 1 minute, I'll be stopping this poll. So please do it quickly to save some time for question answers. I know that you will have a lot of questions in this. It's a more of a concept heavy class, but I'll be happy to solve all of your questions. So quickly answer this so that we have time for question answers. Okay, so if I have 70% of the participation, I'll be moving on because then I will know that you are answering the question. Okay, one more percentage. I have stuck at 69%. Those who have not answered, please answer it fast. Okay, so it went to 70%. Okay, so I'm going to end the poll and 77% of you have given the right answer. Thank you so much. Congratulations to you that you are focused in this class and you are learning something from it. It predicts the next and the next word only in the sentence. And just by predicting the next word in the sentence, we are able to generate this intelligence inside the ChatGPT or large language models. Right? So the concept is very simple. It is just predicting the next word. And by just merely predicting the next word, we are creating this whole document. And that sometimes we think that ChatGPT is actually thinking and answering me, right? But in reality, it is not thinking. It is just predicting the next and the next word only in the sentence. Okay, so how that prediction happens, what is the underlying principle? It happens through large language models, and how to design large language models is what we are learning right now. Okay. So this is the results. I have shared it. 77% of you were right. And so the first step of creating a large language model was we take up all the text that is in the internet, all the text that is in the Wikipedia, social media, GitHub, Pinterest, all these websites, and we put that in one file. Okay. So the next step is to train the model. Now, how to predict that next word in the sentence? How are we predicting that? Right? We are learning how to predict that. Okay, so we need to train our neural networks. That means the network that we have of neurons, artificial neurons, to predict the next word in the sentence. How to do that? So what we will do is we have the text in the whole world. Okay, so what we will do is we will randomly cut the sentence from the training data. So we'll take a sentence, a random sentence from all the text that we have in the world. We take a random sentence and we cut that sentence from the training data. Okay, from middle. So in this example, I take this sentence that Taj Mahal is on the right bank of the river Yamuna in Agra, Uttar Pradesh, India. Okay, so I want to train my large language model to predict Agra or Uttar Pradesh, India, Agra, basically Agra. Whenever I ask where is the Taj Mahal. Okay, so I am training my model to answer me a question about Taj Mahal. So this is one example only I am taking. Okay, so we will do it for all the text that we have in the world. So what we will do is we will randomly cut the sentence. So we have a sentence, we have an information. So the information was the Taj Mahal is on the right bank of river Yamuna in Agra. So we cut Agra from this. Okay, and we ask the neural network to predict the next word in the sentence. Okay, and it predicts something, whatever the knowledge it has prior. Okay, whether it has knowledge or not, whether it is the beginning of the training or whether it is in the middle of the training, whatever the knowledge it will be having of where is Taj Mahal, it will predict the next word in the sentence. Okay, then we will calculate the probability of words. So there will be a probabilistic model which words should come in the next as the next word in the sentence, and the word which has the largest probability of coming will come as the next word. Okay, now what we will do is we will compare this sentence with the original sentence. We already know that this is our original sentence, right? So Taj Mahal is on the right bank of the river Yamuna in Agra. We already know that Agra is the answer. Why? Because we have that data of the world, and that we only cut the sentence from randomly, and we asked ChatGPT to predict the next word in the sentence. Whatever ChatGPT predicted, we compare it with the original word. Okay, and the error is compared. The error is then backtracked, or it is sent back in the neural network, and the neural network weights and biases, they adjust. Okay, so their values are adjusting. So we are adjusting it inside the weights and biases. And these weights and biases, when they adjust, they are adjusted so that it always predicts the correct word. Because the error is sent back, it adjusts, and it is being directed that the next word in the sentence should be Agra. In that way, the neural network will adjust. Okay, remember we were training it with cat images, right? So it is taking some patterns from cats. So these patterns are getting so the weights and biases are adjusted by seeing these patterns in cats. So similar patterns in the text, if it is seeing, then these weights and biases are adjusted, and the next word is predicted. Okay, so I will just give an example of this. So this is the word that we were predicting. That means the Taj Mahal is on the right bank of river Yamuna in Agra. Okay, so we want it to predict Agra all the time. We are training it to know or learn that Taj Mahal is on the bank of river Yamuna in Agra. We want it to learn that. Okay, so how to do that? So we will randomly cut the sentence, this from here, and we ask ChatGPT or large language model to predict the right word. Suppose in the first chance, it predicts Delhi, okay, because Yamuna also flows through Delhi, and it might have taken text that Yamuna is that Delhi is on the bank of river Yamuna. Okay, so here it predicts Delhi with 90% probability. It says that I am 190% sure that the next word in the sentence should be Delhi. Okay, but then what we will do is we will calculate the error. Delhi is not the right answer. We already know Agra is the right answer, and we back propagate that error. Okay, so there is a back propagation algorithm. I cannot explain this in this masterclass itself because it's a whole masterclass in itself. But just the gist of it is that the error is being fed to each and every node in the neural network from the output end to the input end, and the weights and biases are being adjusted to predict the right answer. So the weights and biases, they will get adjusted, and they will get adjusted until and unless it knows that the next word in the sentence is Agra. So whenever a user will ask where is Taj Mahal, it will always predict Agra now, because this large language model has learned that the Taj Mahal is on the right bank of river Yamuna in Agra. Okay, so we will do this with all the text in the world, all the text that is in Wikipedia, thousands and thousands of GBs of text. Randomly cut the sentence, ask to predict. Randomly cut the sentence, ask to predict. And in that process, all the neural network that we have will get adjusted, and it will learn all the English language that is there in the world. Okay, so very, very intuitive idea of how large language works, and very, very simple way of saying the large language model and what is how to create one. But nonetheless, very powerful to understand that we are only predicting the next word, and we are using this neural network type of architecture to adjust and predict the next word in the sentence. Okay, now that prediction happens with the help of transformers. Okay, so what are these transformers? Let's learn about them. Before we go into our transformer in detail, remember that the GPT, so you have used ChatGPT, but many of you would not know what the full form of ChatGPT is. Okay, the full form of ChatGPT is Chat Generative Pre-trained Transformer, GPT. Generative, that means it generates text or images. Pre-trained, that we will explain later. What is pre-trained, we explained right now, that we are pre-training it with the data. Okay, so example of pre-training model is that whenever you ask a new question to ChatGPT, it will always say, as of my knowledge of 2023, the tallest building in the world, that just like I show you here, right? The answer of this. As of 2024, the tallest building in the world is the Burj Khalifa in Dubai, because it is being pre-trained at 2024. When ChatGPT launched its large language model, it pre-trained it in 2024, and that is the only information it knows about the world. Okay, whenever we pre-train it again, it will know more information about it. Okay, so that's when the word pre-trained comes, and transformer is the technology that we will use to train these large language models. Okay, so let me just open this poll of how many of you had heard about transformers before in your life. Okay, so it's a never have I ever question. If you have heard about transformers, then let me know, and if you have not, I'm just sharing the last results. Okay, so that's a question number 5, and I've launched this. So I will give you a 1 minute to answer this question. If you have heard about transformers, then say I have. If you have not, then never have I ever. Don't worry, you don't have to drink anything if you have not heard about transformers. Okay, so I will be just connecting my laptop charger in this meantime. So please answer this question. Okay, so I have received 71% of your votes, and I'm going to end the poll and share the results. 72% of you have heard about transformers. That's amazing to know. And 28% of you have never heard about transformers. Don't worry, we are going to have an in-depth discussion about transformers in today's masterclass. So even if you have never heard about them before, we're going to have a brief introduction of them. Okay, so let's get back. And if you have heard about transformers and you are thinking about these monsters, then you are thinking right. So no, we are not talking about these transformers, Optimus Prime and Bumblebee. They are amazing. They are good for movies. But no, if you have heard about transformers and you're thinking about these, this is not what I'm talking about. And if you're an electrical student and you are thinking about transformers and you're thinking about these transformers, then that's also not what I'm talking about. I'm talking about these transformers, and this is the transformer architecture. And Google researchers, the team at Google Brain and Google Research, in 2017, they launched this paper, Attention is All You Need. And that's a very, very interesting paper to read. That's kind of like a Bible to anyone who is starting their natural language processing journey. And I'm very, very proud to say that there were two Indians in that team, Ashish Vaswani sir, Dr. Ashish Vaswani sir, and Dr. Nikki Parmar ma'am, who were researching at this Google lab. And they said that to understand language, we need to design an architecture which will be called transformer architecture, and it will have a lot of layers like this. And these layers will be helpful in making the computer understand the human natural language. What are these layers and what is the transformer architecture? I'm going to talk about this in detail and how it understands English language. Okay, so transformer contains of two parts. One is the encoder part and the decoder part. So if you see transformer architecture here, so this right part here, the left part here is called the encoder, and the right part here is called the decoder. So encoder and decoder together are used for translation purposes, and it is used in Google Translate, and it is very good in translation. So basically, transformers were developed to enhance the translating capabilities of Google Translate, but we use them as large language model. So this encoder part is not used. So when OpenAI was researching, on this transformer architecture, they kind of like discovered that only the decoder part of the transformer architecture can be used to predict the next word in the sentence or to understand the natural language. So they use this decoder architecture to predict the next word in the sentence, or to use it as text prediction model or text generation. So remember that if anybody asks you, then ChatGPT uses only the decoder part of the transformer, and encoder part is not used. It is neglected. The decoder part of the transformer architecture, and we are coding this. And just to not to be confused this with a hardware, it's not a hardware architecture, it's a software architecture. Basically, how we can program a computer to understand human language, we will be able to, we will use this architecture to program. So first, so think of it as a 5-story building. So there are 5 stories in this, 1, 2, 1, 2, 3, 4, 5, and we are entering from the ground floor. Okay, so ground floor we are entering, and we are exiting from the top. So this architecture is, if I give you a kind of like an analogy, then you can think about it as a 5-story building. Okay, so what happens is, remember that any word in, if you want to predict the next word in this sentence, okay, apples are a type of delicious dash. Okay, so next word in the sentence. Now, as a human, I know what will come in next, because I can understand what an apple means, what type means, what delicious means, and I know the next word in the sentence will be fruit, right? Because of my knowledge of apples and what are the type of, right? I can understand language because I have listened to the language since childhood, and I have read about apples. I have eaten apples, and I know what apples are. But a computer has never seen an apple. It doesn't know what an apple is. It doesn't care about what an apple is, right? Because it doesn't even uh, uh, give any heed to what an apple is. So how to make computer understand what an apple is and how to predict the next word in the sentence is what we will do using transformer architecture. So the first thing that we do whenever we want to train a computer to understand a natural language is we embed these words into computer program. Okay, so we embed this word into computers. So computer doesn't understand apples. It only understands ones and zeros. Okay, so to make computer understand words, we embed them into the language that computer understands. Okay, so how computer understands the language? Quick quiz time. So if I give you this question, king minus man plus woman, can you guess what is the answer of this question? Okay, so I'm launching this quiz, and this is the quiz. So king minus man, you have to subtract man from king and add a woman to it. What will you get? In terms of language, okay, not in terms of alphabets. So in terms of language, what you will get, or in terms of logic, what you will get. If you subtract man from king and add woman to it, okay, so what you will get? All right, so I'll give 1 minute for this quiz so that you are learning and giving the answers. So 1 minute for that quiz. And once we reach more than 70% participation, I will end the poll. So please do it fast so that we have lots to cover. We are still at the beginning of transformer architecture, and we just have 40 minutes. So just do it a little bit quickly. So what I'm asking here is you have to subtract man from king and add woman. Okay, so if I subtract man from king and add woman, what will be? All right, so I have reached 62% of your participation. I will wait till it gets to 70 and end the poll. All right, so 64% have participated right now. Please do it fast. 65 and 66, 67, 68, and 69, and 70%. Okay, so I'm ending the poll right now, and I'm showing you the results. And 64% of you have said queen. Okay, so take a pause at this time and think, how could you just add and subtract a word, okay, and get another word? How could you do mathematics on a word which is only done on numbers? Okay, so this profound concept or context of represented words as mathematical concepts, because computers are amazing in understanding maths. We have been using computers for the last 60, 70 years just to understand math. They can do math better than anyone can, And if I ask you to do 923 multiplied by 672, it will take you a long time to do that. But computers are very, very good in doing that. And if we could take this understanding of how words are related to each other, then we will be able to make computers understand words. So if we could do mathematical operations on words, then computers will be able to understand these words. Okay, so this idea of treating words as vectors. So in computer language, what we do is, so similarly, we can take another example. If I subtract Delhi from India and add Paris to it, it will become France. Why? Because if I'm subtracting from man, that will be just a title. And if I add a woman to that title, that will become queen. If I subtract Delhi from India, then it will become a country. If I add Paris to that country, in that understanding, then I will get France. Okay, so what we do is in in computers, we represent these words as vectors, and these vectors are in a vector space. So I have the limitation of drawing it into a 2D space. So in general, these vectors are so vectors have two definitions. One is a mathematical definition, and one is a physics definition of vector. So a physics definition of vector is a vector which has a magnitude and a direction. And a mathematical definition of a vector will be a point in space, right? So if we can represent these words as vectors, as some points in some hypothetical plane, then we will be able to use logic to have the contextual understanding between words. Okay, so if we could find a way to represent these vectors in the vector space, so this vector space is actually 512 dimensions. So basically, there are 512 dimensions, and this is a scattered vector plane. I will not be able to draw it in a 2D plane, but imagine that there are 512 dimensions, and these words are lying in these 512 dimensions. So words which have similar meaning, they will lie in similar clusters. So words like queen and king, which are titles, right, to a position, to a power, they will lie in same direction of that vector plane. So I put all the words in English language in a vector plane, and in that vector plane, the words which have similar meaning, they will be in a similar direction, same direction. Okay, and man and woman, they will point in a same direction. And if you could do some calculation, like if I take negative of man, add that to king, there will be a title vector, and then if I add the woman to that title vector, then I will get this queen vector. Okay, so one more thing to notice is that vector, all these vectors, their origin is at their starting point is at origin. Okay, so we assume that all these vectors have that starting point at origin, and they are, all these words in the English language are vectors, and two words which have similar meaning, they are lying in the same direction. Okay, now how to make these words as vectors? So the idea is to so in vector, if we translate vectors into computer programming, then vectors transform to matrices. Okay, matrices or arrays. Okay, arrays and matrices. So one way is to use one hot vector, and one hot vector takes all the words in the English language, and we arrange them in ascending order, starting from Aardvark to the last word, which is Zulu. And if we want to encode this abacus, if we want to embed this abacus into word embedding, then we will put the one in fifth place, because in this ascending order of words, abacus comes at fifth place. Okay, so one hot vector is one way of representing all these words in the English language, where all these words have no relation to each other. So all these words will be perpendicular to each other in this vector plane, one hot vector. One more way is to use word count. So suppose we have documents. In my corpus, I have different documents, and in each document, I will count how much time a number has occurred. So if Aaron has come 4 times, so I will create a matrix like this to represent these words. So Aardvark, I will encode or embed Aardvark as how many times it is occurring in a document. So in document 2, it is occurring 1 time, and in document D, it is occurring 1 time. So I will encode it like this: 0 1 0 0 0 0 0 0 1. And Aardwolf is occurring in document 4. It is not in document 0 1 1 2 or 3. So I will just encode it on 4th fourth one, and it is only occurring one time. Aaron is occurring 4 times in document 1, and document 3 it is occurring 7 times. So I will encode it like this. So I will create a word like this. So this will create a frequency matrix, and this way we can also represent word. One more way of representing word, which is very, very common, is we use co-occurrence. How many times a word is occurring with other word? So if a word is occurring with other word in a sentence, there are high chances that that word will have some these two words are related somehow, right? If I say that in most of my English language, apples are coming with fruits, then apple and fruit will have some understanding. They will have some contextual understanding about each other, right? So co-occurrence, will count co-occurrence about how that means that how many times each word is occurring with other word. So we write all these words in ascending language in a column, all these words in ascending language in rows, and we count how many times each word is occurring with other word, and we count the kind of distance also in how much apart these two words are there in the sentence. Okay, so this is one more way to embed word. Then if we want to calculate these two vectors, if you want to know if two vectors are near, we can use Euclidean distance, that is the distance between 2 points in a space. And the words which will have less distance between each other, they will be similar words, and the words which will have more distance between each other, they will be different words. One more way of word embedding is to use cosine similarity. That means to take the dot product of two vectors. So if two vectors are pointing in one direction, then taking the dot product will dot product will be some value. If they are perpendicular to each other, they will not have any dot product. The dot product will be 0, right? So in this case, if there are two words like snowflake and mango, if they are not related to each other, then the angle between these two will be 90 degrees. So we'll be able to detect which words are similar to which words, and which words are not similar or not related to any of the word in the whole English language. Okay. All right. So now what we have done is we have all the language. So we are pre-training right now, right? So we have that corpus, all the words in the English language we have embedded, and now we have this vector space where all these words lie, and the words which are closer to each other in this vector space have similar meaning. Apples, mangoes, bananas, grapes, they will be closer to each other. Okay, they will have similar meaning. Now what we move is we move to second position, which is positional encoding. Remember that we are feeding all these words in parallel to our transformer architecture. We are feeding these words in parallel to whatever programming you are using, whatever architecture, whatever language you are using to program. We are feeding these words in parallel in this architecture, right? And in English, a position of words matter. If I write dogs eat bones, that's a correct sentence. But if I change the position of dogs to bones and from bones to dogs, okay, so if I write bones eat dogs, it is not making any sense at all, right? It is a nonsensical sentence. Although it is grammatically correct, it is a grammatically correct in English language, but it doesn't make any sense, right? So position of words, dog comes first, eat comes second, bone comes next, then only it makes a sense, right? So in this layer, what it does is, because we are feeding all these words in parallel, we don't know which token came when. So we are numbering these tokens one by one. So 1, 2, 3, 4, 5, 6, 7. So now the transformer architecture, it knows which token is where in the sentence. Okay. The third layer is the most important layer. And here the magic happens, which is the masked multi-head attention layer. And then we attach it to a feed forward network. Okay, so I will explain these two things in a brief. So attention mechanism is, so what happens is, in English language, the dictionary meaning of words is different and the contextual meaning of words is different. So in input embedding here, when we were embedding the words, we were using the dictionary meaning of the words, like apple, banana, mango, they are fruits, the dictionary meaning of them. Elephant, cow, goat, they are animals. So the dictionary meaning of these words. So king, queen, they are their dictionary meaning. So we are clustering these dictionary meaning of words, and we are understanding which words mean similar in dictionary. Okay, but when we actually use English language, the context of the sentence changes the dictionary meaning of words. Okay, so I will prove this with an example. Now here, so if you have this example, the elephant could not fit in a car because it was too big. Okay, now it as a English language can be used for a animal as well as a non-living thing. Okay, but the meaning of it will change in this sentence. I just want to give a question, a poll. Right now in this sentence, the elephant could not fit in a car because it was too big. What does it mean in the sentence? Okay, so just I'm sharing this poll. What does it mean in this sentence? Okay, so I lost this one. Yeah. So in this sentence, the elephant could not fit in a car because it was too big. Okay, what does it mean? It can point to elephant. It can also mean car, because the dictionary meaning of it is that it is being used for either an animal or for a non-living thing. Okay, so in this sentence, what does it mean? The elephant could not fit in a car because it was too big. Okay, we'll quickly wrap this up in 1 second, 1 minute, because we have a lot to cover. And okay, so I'm going to end the poll right now because of the time saving that I want to do. So 90% of you said that it points to elephant. Okay, because, and that's logical, because if we are paying attention to big and elephant, then always it will point to because it is defined big here. Car cannot be bigger than elephant, so it always points to elephant, right? But if I change this, now what about this? Okay, so I'm launching this new poll, and okay, and now what if I change the sentence? Now what does it point to? Okay, so now I changed the last word on the sentence only. I did not change the whole sentence. The elephant could not fit in a car because it was too small. Now the meaning of it changed right now, right? As a lot of you are saying car is the right answer. I'll wait for some of the other answers, and I will know that you are at the right track. Okay, so in the previous sentence, it was pointing to elephant because we were paying attention to big. If we pay attention to small, then the contextual understanding of it will change to car, right? So how to solve that? Because the English language, the dictionary meaning and how we use it in a sentence are very, very different. Okay, so I'm just going to end the poll, share the results. 90% of you are still giving the right answer, which is car. Okay. And how to do that is, I will just skip this attention mechanism. This is a little bit of, okay, anyway, let's go through it. So each vector, now you remember neural networks, right? So when we were training neural networks, so each vector is converted into, so we were converting these words into vectors in the embedding form. So each vector is now converted into 3 vectors: the query, the key, and the value vector. Okay, so just go through it, ask questions by the end of this class if you don't understand this, but let me just skim through this concept. Okay, so these vectors are derived by multiplying the input embeddings by trained weights. So the input embeddings of the word and the weights that we are training it with. So if we multiply these input embeddings with the trained weights, we achieve these 3 vectors, which are called query, key, and value vectors. Okay, how to achieve this is not very important. What does it do is important. So what now we do is we multiply the query vector of, so we look at the whole sentence, whatever is this. We were trying to predict the next word in this sentence, right? Apples are a type of delicious something, something, something. So we take the query vector of apple, that means the contextual, the dictionary meaning of the apple, and we multiply it with key, or the understanding of the word, So we multiply it with the key vector of all the words in the sentence. So apples are multiplied with apples. Apples are, so multiplication basically means dot product in vector calculus. So apples are being dot product with apples. Apples are being dot producted with I. Apples are being dot producted with apples are being dot producted with type. Apples are being dot producted with of, and then delicious. And we will do it for every word. Okay, and a value is calculated, and that value will determine which two words have more context, and which words have more context. And based on this value, we will try to we will identify which words we will pay more attention to. Okay, so in this case, the value is 0.145. Apples and apples have context because similar words have more context. Apples and are don't have much context. They might have some context that this is a plural. Apple and type have concept. So type and apples have a bigger value, and apples and delicious have a larger value. So if I pay attention on these words, apples, type, and delicious, because they have larger values, I will be able to predict the next word in the sentence. Okay. Now, what we do is, so we have calculated the values, and now we know which words we need to pay attention to in order to predict the next word in the sentence, right? If I only pay attention to apples and type, okay, apples are a type of, and if I don't pay attention to delicious, so apples are also a type of laptops. So laptops can also be a word in the sentence if I don't pay attention to delicious. So it's very, very important to pay attention to words in the sentence which will determine what words we are going to predict next. Okay, so if I pay attention to delicious and apple are a type of delicious, then snacks can also be a type of answer because snacks are delicious. So if I only pay attention to apples and delicious, then I can also predict snacks as an answer. Okay. Now what we will do is we will feed all of the information to a feed-forward network, which is basically a neural network, and we implement some non-linearity in it because linear systems are not very robust. So to make them robust, we implement some non-linearity in this. So a rectilinear function is used. I will not go into deep of that. That will go out of the scope of this masterclass. Now we have attention to words, which words I need to pay attention to in a sentence, and the next word to predict. And that happens in the fourth layer, which is the linear transformation layer. So now what happens in a linear transformation layer is it takes this last word which we are about to predict, and based on the attention that we are paying to the words, it gives a probability to all the words that are there in the English language. What can be the next word in the sentence? So all the words in the English language will be given based on the attention of the words apples, type, and delicious. Based on these three, we will calculate the probability of the next word in the sentence. So it will be given a score. Okay, so here according to, if we pay attention to apples and type, then snacks can also be a type of apples are also a type of snacks because people kind of like eat them in their free time. Apples are also a type of laptops, and apples are a type of delicious fruit. So all the words in the English language, even if it is aardvark, aardwolf, friend, lamb, snack, snake, Zulu, whatever the words is there in the English language, we are kind of like giving them a score. And the words which have higher score, and we already know that with the pre-training, right? We are pre-training it to predict the next word in the sentence. Now, according to this, the next word in the sentence should be fruit, because a lot of times in my text, apples are being counted with fruits, and some of the times it might also be counted with laptops. So 0.5 probability of laptops also, 1.56 probability that it might also be a snack. Okay. Then what we will do is in the last layer, we will normalize that probability. That means that we add all the probabilities to 1 so that the larger values, they become larger. The smaller values, they become smaller. And the values which have the largest probability, that means fruit has the largest probability, the next word in the sentence will be fruit with 92% of probability. And snacks will have 8% of probability, and laptops will have 1%. Okay, so this transformer architecture we will program it using neural networks. And if we could program our transformer architecture, then it will be very, very efficient in predicting the next word in the sentence. Okay, so before we move on to our session, let's take this poll, and I'm just going to launch this. And yeah, poll is right now here. So what is the mechanism that allows transformers to know about the contextual information of the words? Okay, remember the contextual information is the word here. Okay, not the dictionary meaning, the contextual meaning of this. तो वो कौन सा मैकेनिज्म है जो contextual meaning बताता है sentence words की. Okay. All right, so the options are suspension, transformation, attention, and embedding. Please read the question carefully. We need what is the mechanism that allows transformer to know about the contextual information of words? That means how the words are being used in an English sentence. Okay, so what is the mechanism? Is it suspension? Is it transformation? Is it attention or embedding? Okay, so we will take larger time for this because it needs a bit of thinking. So 1 minute 30 seconds I will give for you to answer this question. What is the mechanism that allows transformers to know about the contextual information of the words? Okay, so I'm going to just end this poll because of the time constraints. And if I share the results, there are mixed responses. I hope that, so yeah, just to avoid the confusion, the terminology that we use, the mechanism that we use is the attention mechanism, because we are, remember the elephant and the car example, contextual information of the word is being only we can extract the contextual information if we pay attention to certain words. Dictionary meaning of words can be done with the help of embedding, right? And transformation is not any word that is used in this, right? Transformers is the architecture. Transformation is not any mechanism. So attention is the right answer, and 37% of you have given the right answer. Many of you are confused it with embedding. In embedding, we only know the dictionary meaning of words. In attention, we get to know the contextual meaning of the words. Okay, so I'm just going to stop sharing this and let's move to fine tuning. So after large language model is trained on a large corpus, it needs fine-tuned. It is fine-tuned according to our needs. So basically, ChatGPT has. So I will skip a little bit of the fine-tuning methods, and I will go dive right straightforward into reinforcement learning with human feedback, because these three I will explain in the next masterclass. Okay. So fine-tuning basically is because ChatGPT is trained on the internet data. Okay, and internet data is not like human language. It is not personal. It is ChatGPT will not be able to answer in a personalized way if it is just trained on the internet data, right? So we need to tune its answers, and it can be done with very different methods: human feedback, dataset fine tuning, transfer learning, few shot learning, prompt engineering. We will be learning these three things in our next masterclass. So I will be explaining the reinforcement learning with human feedback. So when ChatGPT was being created, a lot of humans were employed just to give a feedback to ChatGPT's answers. So if I ask ChatGPT what is repo rate, so this is a standard answer that ChatGPT will generate on the base of the knowledge that it has from the internet. Okay, but a more humanized response will be to understand, to make you understand in a more personalized tone, like this rate is pivotal for controlling liquidity, influencing borrowing cost, and steering economic growth, serving as a key tool in monetary policy. So what ChatGPT did was, whatever responses ChatGPT was generating, they are giving that response to a human, and human being was writing the response in a way that human beings write. And we use that database to fine-tune ChatGPT response, and now ChatGPT is tuned to responding just like humans. So, but what basically a simple example of it is, whenever you ask ChatGPT to generate something, ChatGPT generates something, and you can give that thumbs up and thumbs down. So thumbs up means that it is a good response, thumbs down means a bad response. And that is also a way of fine-tuning ChatGPT according to your needs. Okay, so you are telling ChatGPT that this is the right answer, this is not the right answer. Okay, so that is also reinforcement learning with human feedback. You learned about reinforcement learning in the last masterclass, right? Where we were giving a reward whenever the answer was correct, and we were punishing whenever the answer was not correct. So if the ChatGPT is generating any text, so we are correcting the text that no, this is not a text that you should generate. This is how you should write the answer. And human beings were specifically training ChatGPT on the answers. Okay. This has already been done, and there are some questions. We will take that by the end of this class. And let me just check how much time is left in today's class. We have good 15 minutes before we go to the question answer round. Okay, so I will take the questions. Generally, what I do is when I have a 3 hours of masterclass, basically this masterclass was supposed to be 3 hours, but because of the time constraints, we have moved it back, and that's why it is just to be a 2-hour masterclass with half hour of question answers. So what I do is I take questions because it has become too much of conceptual heavy of the text understanding. But let's dive deep into how images are generated, and let's take questions by the end of this masterclass. Okay, so to understand how images are being generated, we need to first understand the difference between generative AI and discriminative AI. We already know discriminative AI. That means that AI that is used to discriminate whether an image is a cat or a dog in our last masterclass, right? Where we were predicting whether an image was of a cat or a dog. And we were doing it with the help of neural networks. Generative AI is entirely different. That means that we are writing draw a cat and it is drawing a cat for me. Okay. And in discriminative AI, we are giving it a cat image and we are asking it to predict whether the image is of a cat or a dog. Right? These are two very, very distinct things. So similarly, I will skip through this because we have already learned this. So if I want this neural network to predict if this image is of a cat, then what I will do is I will train this with lots and lots of cat images. This neural network will adjust its weights and biases. And the combination of these weights and biases, it will learn about the features of the cat. And these nodes will get fired whenever they see a cat. And whenever subsequently, we will also train this neural network with lots and lots of dog images, and it will be trained to predict dog. So whenever we'll show this neural network image of a cat, it will always predict that it is a cat because it has learned these features from cat. So whenever a cat image is being shown, these neurons will get fired because they have learned those features of cat, and it will predict the cat. Now, generative AI is very different. Generative AI, in generative AI, we will give a text input as prompt, like draw an image of a cat, and it will generate an image of a cat for me. Okay. So how does it generate? I will skip this question because I want to take it by the end of this class. So how does it generate? So to generate the images, there are 3 technologies that we use. One is GANs, generative adversarial networks, and the other one is diffusion, and the third one is stable diffusion. I will be talking about all these 3 things in this masterclass today. So let's learn about generative adversarial networks. In generative adversarial networks, what we do is we use 2 convolutional neural networks. That means that we use 2 neural networks. One is called generator and the other is called discriminator. Okay, so I will just go back to these slides. Okay, so this is a neural network, and we will use 2 neural networks, one of them to generate the image and one of them to detect the image. Okay, so discriminative AI you already know, right? So the generator, we will feed a random noise to generator. So we will feed something which you get on your television when there is no signal, noise signal, right? So these black and white dots. So this can be random dots. So that, and we ask this generator to generate cat image. Suppose we want this generator to generate cat image. Okay. So we feed this to generator. Generator will generate a random image. Okay. So because generator does not know anything about cat, so it generates a random image like this. Okay, image like this. Now discriminator has to tell whether this image is cat or not, because it has been trained with lots and lots of cat images. It knows which features are of a cat and which features are not of a cat. Okay, so it will generated a random image. It goes to discriminator. Discriminator says, no, this is not a cat. Okay, generate again. So the feedback also it will send. A cat has different features. You have generated me whatever. This is garbage. Okay, so generate again. Now generator will again generate something on the base of the information that the discriminator has given. Right? Discriminator said that, no, this is not cat. These are some cat features. Generate an image now. Okay, so generator will again generate a random image because it still does not know what a cat is. Okay, so from the noise, it generated this. Now discriminator says that, no, this still does not look like cat. Generate again. So generator will refine its image and it will generate again. And this happens like multiple iteration times. Okay, not just 2-3 times. It will happen for infinity. Not infinity, but a number of times. That's just a slip of tongue. So it happens for a number of times, and after some time, it will generate an image like this. And again, discriminator says that, no, this doesn't look like a cat because I have been trained on cat data and I know what are the features of cat. Your image does not look like a cat. Again, it generates. So now generator, sorry, it happened too quickly, I guess. So after this, it says that, no, this is not the image of cat. Generate again, and it generated something like this. And finally, this generator will generate an image which discriminator will not be able to detect whether it is generated by generator or or it's actually a cat image. Okay, so in that process, the generator will learn to generate a cat image. Okay, it will generate until and unless the discriminator tells that, okay, this is the perfect image. So until and unless discriminator is satisfied, it will continue generating the image. Okay, so in this way, you will be able to generate the image. Another way of generating image is through diffusion models. So in diffusion models, we generate image from random noise by following a series of steps. So remember, we were also generating image from a random noise in a GAN, right? Generative adversarial networks, where we were using two convolutional neural networks. One was a generator, one is discriminator. Why we call it a adversarial network? Because they two are competing with each other. They two are adversaries of each other. Generator is trying to fool discriminator by generating the image. Discriminator is trying to detect what is the image being generated by generator. And whenever it is not satisfied, it says that generate again. And in that process, the iterative process, it will be able to generate an image that discriminator will say that, okay, pass, this is a cat image. And because it is generated entirely from a noise, it will be an entirely unique image. That means this image will nowhere be in the training data of the discriminator. So that's why we will be able to generate an entirely new cat. Okay. Now in diffusion, what we do is we deliberately add noise to pictures while training the network. Okay, so in diffusion, what we do is, so basically, we take a cat image. Suppose we want to draw cat. So we add noise to these cat images. Step by step, we add some noise, we add some more noise, and until and unless it becomes like this. Okay, so now we take a neural network and we give it a noisy image, and the neural network already knows what the right image is, right? This is the right image. So we ask the neural network that this is the noisy image. Now predict this image from this noisy image. Okay, so it will predict something until and unless it predicts that this is the noisy image. Okay, and in that process, it will learn certain features from this image to construct this. Okay, so from this image, I am constructing this and I'm back propagating the error again and again. And in that process, the neural network learns some features to predict the original image. Now we will add more noise. We will take this image, more noise image. In a more noisy image, we'll have to learn more features to predict the right image, right? So in that process, it will learn some new features. Then we will add more noise until and unless it completely becomes this noisy image, which has no idea about cat. Okay, so but neural network gets trained in that process that now from this, it can reconstruct this. Okay. Now in training, what we will do is, now we will use machine learning. We will train this with lots and lots of cat images. Okay, so lots and lots of cat images by adding the noise in each of these cat images and trying to predict the original cat. again and again. So in that process, when we are training it with lots and lots of cat images, the neural network extracts some features from these cats to predict the correct image. And it learns these features from these cats. Okay. So whenever we ask it to design a cat for me, so diffusion model from this random noise, it will, because it learned the features from when we were training it with lots and lots of cat images by deliberately adding noise to it and asking it to predict the right image. So it will always create a new image of a cat. Okay. The final one is stable diffusion, and stable diffusion is a mixture of CLIP and LDMs. That means that contrastive language image pre-training, CLIP stands for that, and LDMs are latent diffusion models. So I'll take 5 more minutes in this class, and we'll be covering this, and we'll be wrapping it up to question answer round. Okay. So state of the art means that this is the latest technology. So ChatGPT's DALL-E and Midjourney, they use stable diffusion to generate their images. So what happens in stable diffusion is, now you know that whenever we enter any text to a large language model, it takes it as tokens. It divides into tokens, and these tokens are then embedded into vectors, right? And we get these text embeddings. But now, how does a computer know what a dog in English is and what a dog as a picture is? If I want to create an image like a dog wearing a hat, so how does a computer know a dog looks like what and hat looks like what, right? That's the question that we need to solve. And what we do is we do a contrastive pre-training. Basically, what we do is we encode the text and we encode the image together, and we create a matrix like this, like a joint matrix of the text encoding and the image encoding of that image. Suppose we want to encode Pepper the Aussie pup. So we will take pictures of Pepper the Aussie pup, and we will take the text of Pepper the Aussie pup. We will encode this into English language, and whatever vector we get, we multiply it with kind of like correlate it with the image encoding of the same word. So we get a combined matrix of this. And this is the embedding that we will use whenever we are designing or drawing any image. Okay. The second concept is latent diffusion models, and I will not be able to explain all of these concepts into detail in this 2-hour masterclass. But my idea is to give you the spark in you so that you can take it up and convert it to flames, so that you can go to YouTube, you can research, you can read these papers and all about these underlying technologies and how they actually like in reality work. I can just give you an idea of how they work. Okay, so latent diffusion models are so basically what we are doing here is in this encoding, in diffusion, when we were generating, okay, so in diffusion, when we were generating these images, we were adding the noise to images and then generating it from these noisy images, right? But what if we reduce the dimensionality of the image? So this image is a 3-dimensional image. It has 3 components, red, green, and blue. And we encode it into vectors. And what we do is we convert this 3-dimensional image into a latent dimension. That means we reduce the dimensionality, and that reduced dimensionality image we train using the diffusion model. And then when we want to create the image, we again convert this image from a lower dimensional space to a higher dimensional space. So basically, if I give you an example of how to understand this, suppose I want to draw a cookie. I have a cookie in my hand, okay? And I want you to draw a cookie. And you don't see me. I am in a telephone. I am calling you and I'm saying that, okay, I have a cookie. I want you to draw a cookie. So I'm going to tell you some features of that cookie, okay? The latent model of that cookie. So the lower, a cookie is a 3-dimensional model, right? I can see it in X, Y, and Z plane. But a 2-dimensional model of that cookie would be the radius of the cookie and the height of cookie. Only 2 parameters, the radius and the height of cookie. Okay, so I tell you that my cookie is 3 centimeter of radius, and it has a height of 1 centimeter. So can you draw that cookie now? So your friend will be able to draw that cookie. That's the latent. So basically, we are converting from a higher dimension to a lower dimension, and he is converting from that lower dimension to a higher dimension. He's using that information of 5 centimeter of radius and 1 centimeter of height, and he's designed the cookie in a 3 dimension there, right? So the same concept is being used. We convert a high dimensional image to a lower dimensional image, and when we expand that lower dimensional image to a higher dimensional image, we will be reconstructing the same image. Okay, and when we are using these diffusion models, then we are training our neural networks on this lower dimensional space. This will increase the speed of training, as well as they are faster in learning more patterns. Okay. So a final question before we go. There are actually two questions, and back-to-back two questions. I'll launch the first question. This, I guess, all of you will be able to answer. What is the full form of GANs? And is it generative adaptable neurons? It is good. Is it good attractive network? Is it general artificial network, or is it generative adversarial network? So I believe that a lot of you will be able to answer this. And yeah, I'm going to end this poll quickly because I have another question for you. And I'll just end this when I reach 60% of your participation. So 58% I am at right now, 59, and that's 60. Okay, so I'm ending this poll. I'm sharing the result. 71% of you are saying it is generative adversarial network. Yes, it is right. It is just a fact check. You do not even need to remember this definition. Just remember that in GANs, we use two convolutional neural network, and they are both competing with each other. One is detecting, one is generating. Okay, and the final question that is in front of you is this. In diffusion model, we train our model with adding noise to the image in each step. If you think that it is yes, then write yes. And if you think it is no, then write no. Okay. All right, so I will again wait for 60% of participation and then move to the question answer round. Before that, Rashika will announce certain things, and I will also be opening the uh, attendance form. Okay.
Hello, students. I guess there is some network issue from Amit sir's end. Please wait for a minute. Amit, your mic is mute. You're on mute.
Okay. Yeah, so I just got kicked off from the meeting. So I guess this is the question that we were there, and I'm just sharing the results. And 84% of you said yes. In diffusion models, we train our model with adding noise to the image in each step. Okay, congratulations for saying that, and I am going to share my final slides. Okay. So before I open the question answer round, here there is attendance form for those who don't have any questions. But before that, Rashika has some announcements. So over to you, Rashika, before I open it for question and answers.
Yeah. Thank you, Amit, for an excellent and engaging session on artificial intelligence. Dear students, please provide your feedback by filling out the attendance form. The link has been shared in the chat box by my colleague. Also, students, weekend is here. So I would request everyone to take out some time to complete the learning plan. Also, you need to complete the learning plan as an individual, but not as a team. The other deliverables you need to complete as a team, but specifically when I talk about the learning plan, that has to be completed by an individual. Additionally, we will be circulating one video by today evening wherein we will be showing you the path of where all your deliverables are. The another very important information that I want to share with you is that please see to it that your sponsoring organization is CSR box. Platform registration link has been shared with you in the Word document of recordings and resources. Now, Amit will have a question answer round with you all. If you have any doubts, please feel free to ask Amit. If you don't have, you can leave the meeting and you can start completing the learning plan.
All
Over
right.
to you.
Thank you so much, Rashika. And I congratulate you. This is the ending of end of today's masterclass, which is on generative AI. We will be meeting again on the third masterclass, where I'll be teaching you the art of prompting. That means how to generate a better response using all these large language models. Before that, I'll just share my attendance form with you. You have been amazing today. Your answers have always inspired me throughout this lecture. This lecture was a little bit of contextual heavy. That means that it was more of like how to design our large language models, not in code but in theory. But it will help you build solid concepts in when you are stepping in your journey in AI. So if you have any questions, I'll be able to solve your questions in the chat box. And please answer the question. Ask the questions in the chat box, and I'll be able to read your questions and answer all your queries. And please keep practicing. Those who are leaving this meeting after filling up the attendance, I request you to, if you are forgetting any of the concepts, refer back to the video. The video is being shared on YouTube on CSR Box channel, so you can go back there. You can watch the whole video there. Also, please tell your friends who are not participating in today's masterclass because of the time shiftings that go back to the video and learn the concepts from there. Also, it is very, very important to complete your Fundamentals with Artificial Intelligence course. And after completing, please let the CSR Box team know. All right, so I might have got some questions in the chat box. Let me just quickly open that. If you have not been able to send the questions, please. Okay. So I would request the team to share the attendance link in the chat box so that everyone can get it. Kushi is asking, in generative AI, what are the main key points I should learn? So to learn about generative AI, there are two types of two type of learning that you can do. Is one, how to create a generative AI, or how to understand the underlying principle of generative AI. That was what the class today about. And second is how to use them, right? So the core concepts should be, if I talk about mathematics, then I would talk about probability, calculus, very good understanding of vector space, and vector algebra, linear algebra for that matter. And these four, if you talk about probability, calculus, vector space, linear algebra, if you are focusing on these four concepts in mathematics, then you will be able to model your world problems into computers. Second thing is to understand the transformer architecture. And a brief introduction was in today's class. You can always go to the attention is all you need research paper that was the origin of this transformer architecture. You can read how they have calculated and what is the modeling that they have used. And then you can also learn about how to fine tune your large language models. So fine tuning is, so basically there are different large language models in the world right now, and they might differ in the number of parameters that they have. So ChatGPT is 175 billion parameters. Then there is Llama of Meta. So, and they are of various flavors, like 70 billion parameter model. There is a 7 billion parameter model. So there are small language models also. Mixtral is one. And we have our in-house Greenite model for IBM, which we use for natural language processing. So you can learn how to fine tune these models. And one more thing to really understand about is to get mastery in one of the programming languages that I mentioned, like not the mastery in writing the code, but in algorithms and the problem solving mastery by coding. So if you have these key points in mind, like mathematics and the architecture and the coding part, and fine-tuning them, then you will be able to learn in depth about generative AI. Otherwise, if you want to learn about how to use these generative AI tools, then you will be needing to learn prompting or prompt engineering, which I will be covering in my next masterclass. So yeah, I will see you there. Some other questions I will read from Hardik is asking, Sarvi, here two terms.